Let's again look at properties of square roots. The square root of a perfect square number is a rational number. Now, the square root of a positive real number that is not a perfect square is an irrational number. And you know, up here it really should have said a non-negative. So the square root of a non-negative perfect square number, oh, a perfect square number can't be negative, okay, is a rational number. The square root of a positive real number that is not a perfect square is an irrational number. So two new terms, rational and irrational. So the square root of 8, is it rational or irrational? Well, it's not negative, and it's not a perfect square, so it's irrational. Since 8 is not a perfect square, but it is positive. I actually think the problem here is that I'm left-handed and I keep hitting my hand on the board. Okay, the square root of a negative real number is not a real number. So if we take the square root of a negative number, the result is not a real number. So here, -5 is a real number, but when I take the square root of it, because I'm taking the square root of a negative, I get a number that is not a real number. Let's try to get this straight in our minds now. Let's start down at the bottom part. If it's real, then the radicand is positive. But if it's not real, the radicand is negative. Now let's go back up to rational and irrational. When it's rational, the radicand is, well, non-negative. For irrational, it actually has to be positive. What's the difference? 0. 0 is a perfect square. We could take the square root of 0. It is neither negative nor positive. So in order to say we want all the positives and 0, we say it's not negative. On the other hand, here we can make a stronger statement. We can say that when it's irrational, it's actually positive, because 0 is the only number that is neither positive nor negative. And of course, when the radicand is 0, we have a rational situation since it's a perfect square. Okay. In addition, when it's rational, the radicand is a perfect square. And when it's irrational, it is not a perfect square. So we can make a general statement here, actually. When it's rational or irrational, it is real. Because to not be real means the radicand has to be negative. And in both these cases, the radicand is not negative. So when you're looking at these, the first thing I do is decide whether or not it's real. If it's not real, the radicand is negative, and we're done. If it is real, then we look here. Well, is it a perfect square? If it is, then we have a rational expression. If it is not a perfect square, then we have an irrational expression. So what we'd like to do is, for each of the following, we want to decide whether the expression is rational or irrational, real or not real, and then if it is rational, we want to evaluate or simplify. Okay, well, first of all, even though it was ordered the way it is, I'm not going to do this first. I'm going to do this first. Is it real? Is the square root of 4 real? Is the radicand positive? Yes, it is. Then it's real. Let's go through and look at them. Is this real? Yes, the radicand is positive. Is this real? There's a negative out here, but there's no negative inside. Therefore, it is real. Now we have a negative radicand. This is not real. Therefore, it can be neither rational nor irrational. Again, radicand is positive, so it's real. Radicand is non-negative. It's real. Again, no negative, it's real. No negative, it's real. There's a negative on this next one, but it's out front, so that's okay, it's real. But looking at this one, the negative is under the radical symbol, so it is not real. So it can be neither rational nor irrational. Here we have a negative, but it's out front, so this is real. And again, a negative, but it's out front, so it's real. Okay. We're going to go back to all the ones that are real and determine whether they're irrational or rational. Do we have a perfect square? Is that on our list? Well, 2 squared is 4, so this is rational. So therefore, we need to evaluate this or simplify. What is the square root of 4? What number squared equals 4? 2. Square root of 8. Is 8 on our list? Is 8 a perfect square? No. 2 squared is 4. 3 squared is 9. This is irrational. We have a negative out front, and then we have the square root of 16. So the first question is 16 a perfect square? Well, that was on our list. 4 squared is 16. So we keep our negative, and the square root of 16 is 4. Now, this is a perfect square, but we've already used up the square root. We don't square root again because we wound up with a square root. What number squared is 16? 4. We're done. Okay, the next one was not real. What number squared equals 1? Well, it is rational because it's a perfect square. And in fact, 1 squared equals 1. We said before, 0 squared equals 0, so the square root of 0 is 0. So it is rational. And we can evaluate it. We can say the square root of 0 is 0. Now we see fractions. Well, if the numerator and denominator are both perfect squares, then the fraction is a perfect square. And in fact, 1 squared equals 1. And 8 squared equals 64. So this is rational. And in fact, it is 1 over 8. What happens if I square 1/8? I get 1 squared over 8 squared, which is 1 over 64. Okay, first of all, look to the right of the decimal. There are 2 digits. Outside of if they were ending zeros, because they would be meaningless. Now, is 4 a perfect square? Yes, it is. There are an even number of digits to the right of the decimal. So guess what? This is a perfect square. So this is rational. And in fact, since 2 squared equals 4, that's going to be in the vicinity, but now I have to worry about the decimals. I need the decimal to move over 2 places. Well, half that, and that's what I get. I need 1 digit to the right of the decimal. If I had had the square root of 1, 2, 3, 4, 5, 6. Okay. It's still going to be 2, because 2 squared equals 4, but I need to move my decimal over 6 places, so half that would be 3. So I need this 2 to be 3 decimal places, the 3rd decimal place over, so I need some zeros in here. You don't really have to worry about this because you're going to use your calculator, but I wanted to expose you to it a little. Okay, the next one, we have 2 over 49. Well, is 2 a perfect square? No. So this is irrational. We said this wasn't real, so it's neither rational nor irrational. Okay, the negative out front doesn't matter. Is 36 a perfect square? Yes. Are there an even number of digits to the right of the decimal? Yes. Then this is rational. Now, 6 squared is 36. There were 4 decimal places to the right here, so I need this to be the second one over, half of that, right? Half of 4 is 2. So I need a placeholder, and that's the answer. Whoops, I forgot the negative, didn't I? Okay, 27, is that on our list? Well, 5 squared is 25. 6 squared is 36. So this is irrational since it is not a perfect square.